For those of you who don't know, Brain to Brain went commercial in 2014. They clearly have had this and been working with it for quite a while. In 2013, Direct Studies Interspecies Brain to Brain Interface. In 2014, Human to Human. In 2015, Network to Network, plus Biodirectional B2BI, going both directions. And in 2019, it was multi-sender to a single brain B2BI. Now let's go over here. In 1875, they discovered the presence of electrical signals in animal brains. In 1924, they recorded the first electrical activity of human brain using EEG. In 1973, they connected the brain with a computer and coining the term brain-computer interface. In 1998, the first implantation of BCI in the human brain. In 2004, the first implantation of commercial brain-computer interface into a human brain. Commercial brain-computer interface into a human brain. In 2016, creating the world's smallest and most efficient wireless implant called Neural Dust. They've had Neural Dust since 2016. That's 10 years ago. Now, let's go over here, and we're going to read. Human to human, closed loop control based on brain to brain interface and muscle to muscle interface. Novel communication techniques have always been fascinating for humankind. This pilot study presents an approach to human interaction by combining direct brain-to-brain interface and muscle-to-muscle interface in a closed-loop pattern. In this system, artificial paths, like data flows, functionally connect neural paths, nerves. The intention from one subject, sender, is recognized by using EEG, based brain-computer interface, which is sent out to trigger transcranial magnetic stimulation on the other subject, the receiver, and induce hand motion. Meanwhile, TMS results in a significant change on the motor evoked potentials recorded by EMG of the receiver's arm, which triggers functional electrical stimulation applied to the sender's arm and generates hand motion. Human-controlled loop and automatic control loop experiments were performed with 6 pairs of healthy subjects to evaluate the performance of the induced mechanism. Results indicated that response accuracy during human-controlled experiments was 85%, which demonstrates the feasibility of the proposed method. During the automatic control test, 2 subjects could accomplish repetitive and reciprocal hand motion control up to 85 times consecutively. Novel communication techniques, in which someone else can reach through your body with this electrical connection and move your arm. The conventional interactions between 2 humans or animals basically depend on vision, audition, voice, olfaction, or touch. However, new technologies such as brain-to-brain interface and muscle-to-muscle interface have been proposed based on the unconventional approaches to explore the novel concept of interactive communication. Brain-to-brain interface, which emerged as an extension of brain-computer interface, aims to transfer information between 2 individuals merely using their brains without any intentional physical motion. This technique was first tested on communication among two brains of a pair of functioning rats to jointly learn and move in synchrony. Brain-to-brain interface was also used to successfully establish artificial information transfer pathway from a human to a rat using EEG and transcranial focused ultrasound to control a simple motion of the rat's tail using BBI, because they wanted to control the rat's tail. In a later study, the first direct brain-to-brain interface between two humans was established, which investigated the feasibility of decoding a command from a sender's brain by EEG and forcing a receiver to follow the command using transcranial magnetic stimulation. Analogously, internet-based human brain-to-brain communication also succeeding in implementing conscious word transmission over a long distance, exploiting EEG and TMS by means of Bacon's cipher. BBI has inspired other interesting applications. By adopting steady state, visual evoked potential based BCI for the human and applying invasive neural stimulation to a cyborg cockroach, the human could control the cockroach to walk along a trajectory. Although some achievements have been accomplished through establishing functional BBIs, the previous work just focused on single-way communication and realized open-loop control between two subjects, i.e., only the sender can control the receiver.